We are going to visit the same example again for Riemann sums for computing the area between the graph of this curve and the x-axis between 0 and 1, because the previous video, the quality didn't come out to be very clear. So I'm going through prepared slides in here, and I'm leaving the other one for you in case any of you wanted to see the dialog boxes and the way the computations were done. So our objective is to use the Riemann sums to approximate this area. So what do? Well, we approximate it by rectangles, and here we have taken a partition of 5 equally spaced points, or actually there are 6 points in the partition, and there are 5 rectangles here of the same width, and in which we are taking the right end point to determine the altitude of the rectangle, or the length of this side of the rectangle. So each rectangle is 0.2 units wide. Okay, so we'll go ahead, compute the area, and to compute the area, what we have to do, this one will be multiplied by this height, and this height is determined by the value of this function at x equals 0.2. Okay, so what happens is that we have, see, this height is square root of 1 plus 0.2 to the power 4, and this one will be determined according to 0.4, this according to 0.6, this according to 0.8, and this according to x equals 1. Okay, so if we add those up, what do I get? I get this, approximately this as the value of this area, and we can see right here that this is kind of an overestimation because we are having this extra area included in here, and we'll see how we handle this problem. Okay, so in this case, our scheme would be that we will go on taking more and more rectangles with narrower bases so that we can get a better approximation. Okay, so in order to do that, and just to see that if we have our calculations automated, then coming up with a way of writing them in shorter form, as I'm using with the summation notation, will be helpful. So here we have some of these 5 terms, and you can see everywhere the width is 0.2, which I'm going to take as 1 over 5, 1 for the width of the interval over which we are computing the, over which we are finding the area. So you can see right here, I have 1 times 0.2 to the 4, here I have 2 times 0.2 to the 4, 3 times, etc., etc. So what we are doing, if we just do this, that I'm writing 1.2 as 1 over 5, and I'm taking I for 1, 2, 3, 4, and 5, and letting I range from 1 to 5 here. And if I compute that summation, then the summation will simply be, again, just the same value that we had before. Okay, so what we are going to do now is that we are going to take, we are going to increase the number of rectangles, and which is going to decrease the length of the base of the rectangle, or width, or whatever you want to call it. Okay, all right. So here, this time what I did, I took 10 rectangles. Okay, so each one of them is 1/10 unit wide. Okay, and here the height is determined by the value of the function at x equals 1 over 10. Here x equals 2 over 10, and I is varying from 1 to 10 to account for all these 10 rectangles, and the value comes out to be how much? This much. Okay, 1.11 is slightly smaller than what we had before. Okay, so now what we have, I think, yeah, we have 50 rectangles here. So each one of them is 1 over 50 units wide. Okay, so if we look at the sum, I think I went to the previous one, right? Okay, just a second. See, that's what happens when I'm doing it. Yes, here is the correct one. I'm sorry. So you can see this is slightly smaller than before. Okay, so when we increase these further, like this time I have how many? 100 rectangles, right? And then this looks like a pretty good approximation, and after that I don't think that I'll be able to draw any picture any better or closer. Okay, so we will see this, that how do the values like stabilize. So here I'm taking 1000 rectangles, and you can see it has stabilized up to what, 3 digits after the decimal. Then I did this, went to 100,000. So we are kind of, gotten this far. All right, so let's continue in this manner. So here I have gone from 1000 to 1,000,000 rectangles, and you can see that it's it appears to converge, and it will converge. Okay, so if we look at that with a different approach, earlier we were overestimating. Now if we, in this case, I mean, this is an increasing function. If I go by lower rectangles, then you can see we will have an underestimation, and the change will be this time, that each rectangle, the altitude, instead of being determined by the right end point, it's determined by the value of the function at the left end point. Okay, so when that happens, what would happen is this, that here, right here we will be doing it with the value of x at 0. So I'm just taking I minus 1 instead of I as in the previous case. Okay, so here if I did like with these 5 rectangles, you can see this is lower than the value that we had before. Okay, and if I look for 1000 rectangles, and here is the here are the lower sums, okay, with the altitude determined by the left end point. So this value is lower than this value. Okay, and if we further look at, and you can see that, they're converging. So if we define that limit that we will get to be the area between the curve, that's what we defined as the definite integral of a square root of 1 plus x to the 4. Okay, and that is what? That is this value in between, approximated to these many digits after the decimal sign. And now we are going to see that how do we do these calculations using our calculator. Now I computed these sums using that software called Scientific Notebook. Now let's try using our calculator, that is TI-84, to get the sum of these terms. So see, what we are doing here is that we got this sum, which we abbreviated as this here using the summation notation. And here I just did this, changed I to x, okay, just because the calculator will take x more conveniently. Okay, so what we are doing here is this, that notice we are obtaining the sum of what? 5 terms here. Okay, so we are obtaining sum of a sequence, all right, that is defined in terms of x, that put, okay, so sequence as a, let's say sequence is a function of x, all right, and of course we are going to go for only a finite values of x. Okay, so in this case we are going from 1 to what? 5. All right, so let's pull up the calculator. It's right here. Okay, now, and we want to compute what? Sum of this sequence given by this. Now we can look for these terminologies from the catalog, but in this case, if you just went to this list option, okay, go to math, this sum is right here. Okay, then go to list again, go to options, the sequence is right here. Okay, and then my sequence is defined by, okay, here we go, it's square root of 1 plus, and then what? X over 5. Okay, to the power 4. All right, and then we have x here, and then we are going from where to where? 1 to 5, and let's see what we get. Okay, we did pretty good. We approximately got the same value, and of course the scientific notebook took us much farther. Okay, now so this was the way we entered it. Now let's say we have to obtain, or we want to obtain this value here. Okay, that is for a Riemann sum of 100 rectangles. Okay, so let's pull up the calculator again. Now what I did here is this. Just to avoid any syntax error, for convenience, I went ahead and entered the function already. Okay, so because in this case, instead of writing the entire expression the way we did before, I can just pull this y1 up the way we worked on Newton's method. Okay, so first let's quit out of here, otherwise it'll overwrite things for us. Okay, so here we go to list. All right, math. Then we are going to go to sum. Okay, I could have gotten through second enter. Let me not just say too much here. Okay, so there we go. All right, sequence. Okay, now what do we need? We need a y variable, right? So, and that we entered as y1. You could have entered it directly, but there'll be too much entering here if you did that. Okay, so we have x, then we got to 1, and how far are we going? We are going through 100. Okay, let's see what we're gonna get. Okay, all right, yes, and then it stopped right here, right? Okay, good. So that's how you can use the calculator to obtain these values. Okay.